let's look at a few examples of solving formulas. So this is where, instead of having an equation with only one variable and solving for that variable, for instance, maybe we have an equation like this, a very simple equation, 4 equals 2x, one variable, we have a 4 and a 2. Now we're going to take what I call a formula, or an equation with multiple variables, and now we want to take this equation and we're going to solve it for p, which means I want to take this equation I equals PRT and solve it for p, which means get p by itself on one side. So I'm going to have p on one side and everything else on the other side. Now the reason I wrote this 4 equals 2x because I want to show you that the same rules that we learned and that we used to solve this equation with one variable, we're going to use the same rules to solve this equation. For instance, and maybe you don't even think about these as rules because you know them so well, if I was going to solve this equation for x, you notice I have 2 times x. I have a number times x. And all of you know that to get x by itself, I simply divide both sides by 2, and then I've solved that equation. Now if I look over here, I want to apply the same principle. In this case, I almost think of it like p is the variable I care about, and the rest of the variables are not so important. As a matter of fact, just to make it clear, let me rewrite this. I'm going to move the RT in front and then actually make it very clear that I can think of this as I equals RT times P. Now if we go back to our example with numbers, when I had a number times my variable, how did I get rid of or move that number? I divided both sides by whatever was multiplied by the variable. We'll apply the same principle here. Instead of a number, instead of a 2, I have these two variables RT, but they're still multiplied by the variable I'm trying to solve for. So what could I do to get rid of or to move this RT? Well, what did I do over here? I divided both sides by whatever was in front of the x. Here, I'm going to divide, I meant to say multiply, I meant to say divide. Here, I'll divide both sides by whatever is in front of the p, or whatever is multiplied by the p. And therefore, on the right-hand side, you have p. On the left-hand side, you have I over RT. So now we have solved this equation for p. Oh, let me do a few more examples just so you get the feel for it. How about this one? P equals 2L plus 2W. This is actually the equation for like the perimeter of a rectangle. But before I do this, now here I have 3 variables, P, L, and W, and I want to solve for W. So somehow I want to rearrange this equation or this formula to get W by itself. And as a way to compare, I'm going to go ahead and write an equation that I'm going to use just some normal math. How about if I tried to solve 10 equals 6 plus 2x? Now if you look at this, I think most of you probably think, oh, that's pretty easy to solve. But let's think about actually what the steps you go through to solve this. you've done this for so many years, you just do it instinctively and you don't really think that you're actually following steps or rules. But the first thing we do is, we have three terms here. The first thing we do is we use addition and subtraction to get all the terms with the x on one side and all the terms without an x to the other side. Well, to do that, I'm going to put the numbers on the left-hand side. I need to move this 6 to the other side. The way you move a term to the other side, in this case, since it's positive 6, I'm going to subtract 6 from both sides. And therefore, I have a 4 equals 2x. All right. Let's think about my little formula here. If I'm trying to solve for w, that means I want to get all the terms with a w on one side by itself and all the rest of the terms on the other side. I have three terms. You notice only one term has a w, so I want to get this term by itself, which means I want to move the 2L to the other side. And in the same way, when I wanted to move the 6 to the other side, I subtracted 6. In this case, I can subtract 2L from both sides of this equation. And on the left-hand side, I have P minus 2L equals, on the right-hand side, 2W. So just like my equation with numbers, I have the term with the x by itself on one side. Now I have the term with w by itself. The other side's a little bit messier because these are variables. I can't combine them. But now if I look over here, if I wanted to finish this equation and solve for x, what would I do? Well, I need to get rid of that 2, and it's 2 times x. The way we move or get rid of that 2 is we divide both sides by 2, and you end up with x equals 2. The same principle applies here. If I want to get w by itself, and right now it's 2 times w, to get rid of that 2, I divide both sides by 2. And I end up with w equals p minus 2l over 2. Granted, the formula looks a little bit messier because you have these extra variables, but now we have solved for w. Let's do a few more, just so you get the hang of it. So what we're really doing, we're really applying the same rules you used when you solved equations, but you just probably weren't aware of it. Here's actually a pretty straightforward one, but I want to show you something. How about I give you r equals v over I. I think this might be like Ohm's law for electricity. And we want to solve for I. We want to get I by itself. A similar example with just numbers would be 2 equals 10 over x. Here, the variable I want to solve for is in the denominator. I need to get that variable out of the denominator, and the best way is just to clear fractions, or in this case, it's simple enough that I would just multiply both sides by x. So then I have 2x equals 10. Well, the same thing is true for my formula. I want to solve for I. Right now, I is in the denominator. If I want to move the I to the top, I multiply both sides by I. And then I have IR equals V. And now, for the 2x equals 10, if I want to solve for x, I have 2 times x. We've done this before. What do? You divide both sides by 2. X equals 5. So over here, the same idea applies. I'm trying to solve for I. I want to get I by itself. Right now I have I times R. The way to get rid of or to move that R is to divide both sides by it. Okay, so that's the idea. Let me just a couple of quick more ones, maybe a little more involved. Let me do this one. It's got a little more going on. Here's the formula. S equals HW plus HL. And we want to solve for H. And then an equivalent kind of number problem, I'll call it a number problem, is 10 equals 2x plus 3x. Now if you look at this problem on the right, and you were asked to solve it right away, you would just say to yourself, well, 2x plus 3x equals 5x. And that's absolutely correct. You probably didn't realize there is a principle behind that, which you probably never thought about. And you know what the principle is? It's the distributive property. It's almost like you factor out an x, and then in the parentheses you have 2 plus 3. Now 2 plus 3 obviously is 5. And that's how you end up with 5x. Well, over here, look what's going on. I'm trying to solve for h. All the terms with an h are on the right-hand side, so I don't need to move anything from side to side. And the s is on the other side. But now I have h in both terms. So just like over here, where I had x in both terms, I factored out the x. How about over here, I factor out the h? So I have h times in parentheses w plus L. Now going back to my number equation, now that I want to solve for x, what do I do with the 5? Anytime you have a number multiplied by your variable, you divide both sides by that number, and then you've solved the equation. So what do I have over here? Well, here's the variable I'm trying to solve for, h, and now it's multiplied, but it's multiplied by a whole parenthesis. Well, if I want to get the h by itself, how about I just divide both sides by the whole parenthesis? And when I do that, I find up with h equals s over w plus L. And now I have solved this formula for h. So at first these formulas can look a little messy and a little tricky, but if you try and take a step back and think of all the things you did to solve an equation with numbers, then usually you can figure out the formula.